Hello all. As we know that we are talking about the navigation, today we will be talking about the translation. So to achieve the translation motion, we have three axes, of course: left, right, top, down, up and down axes. So let's look at how actually we achieve this up and down motion. It is very simple, as you've seen that it is same phenomenon which we use for our takeoff and landing. We increase our motor speeds, which actually make our drone to move upward, and we decrease our drone speed, which actually makes our drone to move downwards. It is as simple as it is. So to achieve the left and right axis motion, we are going to use the phenomenon of roll and pitch angle thing. So to move on the left side, so we're going to bend towards the left side. So for that, what we're doing is that we're increasing the right motor spinning. We're increasing the motor spinning on the right motors, and we decrease the motor spinning on the left side. So this actually make our quadcopter to bend along this axis like this shown in the picture. So when we have something like this, you can see that there is imbalance in the force. So we have our force of a thrust, which is now with an angle, the angle which we made, and we have a gravity always moves points downward. So you can see that at this point we're actually compensating our gravity with the vertical component of the thrust force which we created. But we still have a horizontal component on the left side direction which points towards the left. This induces a leftwards acceleration which makes our quadcopter to move on the left side of the direction. So this actually makes our quadcopter to move on the left side. Similarly, to achieve the right side direction motion, we do the same thing in opposite way. So we're going to have an angle this side on the right side, which make our quadcopter to have a horizontal right side component, which make our quadcopter to move towards that axis. So that is how we achieve uh, the motion along the left and right axis. So the same thing could be used for front and back. It is difficult to show here in the 2D plane, of course. So the thing is, we increase the motion and the spinning on the backward motors, and we decrease the spinning on the front motors, which make our quadcopter to bend on the front side and create that force towards the front side, so which makes our drone to accelerate towards the front direction. So to achieve the backward motion, we do it in a reverse manner. And this time we have that angle on the back side, which make our quadcopter to accelerate towards the backward axis. So this is basically how we achieve the front, back, left, right, and up and down motion of the drone. Now let's go and program our drone to do some navigation. Hello all, welcome to this practical session in which we are going to implement our translation motion. We are going to give a position to our drone to reach, and after that we are going to use a velocity vector. We're going to provide the velocities along x and y and z axes to achieve those velocities and performing the translation. So as you can see that as I mentioned before that it uses net coordinate system. So down is actually um, positive, whereas up is actually negative. So be aware of that. So up means negative and down means positive. If you give a positive velocity or positive value along the z-axis, it's gonna go underground. We don't want our drone to do that. We want it to climb. For that, we are going to give a negative value. So let's check the script today. So I'm using the previous script and I'm just adding on that. So for the translation motion, what I'm trying to do is that we're actually using a function called move to position. So this is actually making us to reach a certain position based on the coordinate system. Considering the place where we start is 0, 0, 0. So which means this place is actually 0, 0, 0. So what we're trying to do in our script here is that we want it to move 6 units front and back axis, so which is going to be 6 units front, and 1 unit left and right, so which means 1 unit right, and -4 here represents the up and down, so we want to reach up 4 units up, and we want it to be done within 2 seconds, and the vehicle name is of course our vehicle name. So let's go and execute this script. So you can see that the vehicle is moving forward and increasing the altitude, and you can see actually it is a little bit out from the center because we want it to move along 1 unit towards the right. And if you can also observe that it's actually achieving this translation by providing some angle along the roll and pitch, which we have also seen in the last video, and we have talked about the science behind it now, and we can see that that is how we're actually achieving the translation motion towards that horizontal component which we get. So what we're trying to do now is that we're going to provide the velocities along the x and y and z axes to reach to a certain point. This is the better way which we provide to do, because we don't know the coordinate systems all the time, right? So that's why we provide the desired velocities based on the displacements we are seeing, and we tend to achieve our goal based upon providing the velocities. So the velocities is the function which we're going to use mostly in the coming tutorials. So the function is called move by velocity. So here this is x velocity, and this is y velocity, and this is z velocity. So 4 meter per second along x, 0.5 meter per second along y, and -2 meter per second along z. So I want this velocity to be executed for 5 seconds. So that's why 5, and the vehicle name, of course, vehicle. So let's go and give this velocity to our vehicle. Okay, as you can see that it is moving all along all these axes because of the velocity, and it reached at high altitude as well. So we have given 4 meter per second for 5 seconds, so that's the displacement we're having, and -2 meter per second along z for 5 seconds, which means we should be at 10 meter altitude at this point. So you can clearly see that. So that is basically about the navigation with our vehicle. So we have seen how we're going to achieve the rotation by giving the rotation position and as well as the rotation velocity. And in this tutorial, we have seen how actually we are navigating with translation by giving the position and as well as the velocity vector. So that's all for today. And from next week onwards, we're going to cover some crucial sensors which we need for the drone, and we're gonna do some fun with our sensors. So I will see you all in the next week, and thank you very much for checking the video.